how do we solve the assertion and region question. The assertion and region question, we just try to attempt them without thinking. Without thinking, we try to attempt that which one will be the correct one without giving any thought. So just see here, first of all, how our thinking process should go with it. First of all, we just have to read the assertion. Okay, like this. Read your assertion, and if your assertion is correct, so write over there true. In front of assertion, write true. If your region is correct, so in front of the region, write here true. If the region is false, write over there false. And then go on for the options. Then go on for the options, that which option can be the correct option for you. Okay. So the first question, see here question number 16, assertion, the connecting wires are made of copper. So is it correct? Rene, is this correct that the connecting wires are made of copper?
Yes, sir.
Okay. So if you are perfectly correct that it is correct, the connecting wires, they are made of copper. So we write here true. And the connecting wires, they are made of copper only. So you are correct. Then the reason is copper has a very high electrical conductivity. So first thing, do not forget about the region. What was given in the assertion, forget about the assertion and think about the region. That copper has, think that just this statement, that copper has very high electrical conductivity. So Rene, is this correct to say that copper has a high electrical conductivity?
Yes, sir.
Okay. Amatur Rahman, is this correct? Copper has a very high electrical conductivity.
Yes, sir.
Okay. So this one is also true. Now, the only options which we can choose now we can choose either option A or option B. We cannot choose option C and D, right? As in the option C, it says assertion is true, region is false. Option D says assertion is false, but region is true. There is an option E also which says both assertion and region are false. So we cannot choose any of these three options. Okay, these we have removed. We are only left with these two. Okay. So first one says both assertion and region are true. And R is the correct explanation of A. Then the second one says both assertion and region are true, but R is not the correct explanation of it. So now tell, can the region explain the assertion? Is this the reason why we use the copper wires as connecting wires?
Yes, sir, it is the reason.
Yeah, it is the correct reason. That is why we use the copper wires as the connecting wires. So therefore, your correct option will be option A. Okay. So for your simplicity, I'm just taking these options at a common place. We have our options here. And we just have done question 16. Now question 17. Assertion says the resistance of a given mass of copper wire is inversely proportional to the square of length. So is it correct?
No,
The
sir.
resistance of a given mass of copper wire is inversely proportional to the square of length. Have you studied this anywhere? Amatur? Rene?
Yes, sir.
Medha Ansini. Yeah, Medha Ansini, can you tell? Is the assertion true or false? Just read the assertion and think of it if it is true or false. Yes, Medha Ansini.
Sir?
Is the assertion true?
Sir. It's Tracy, sir.
Yes, Shashi.
Sir, I will have to join through two devices, sir, because the mobile is not convenient for me. It's too small, so I'll be joining through laptop, and for mobile I'll use the audio.
Okay. Or you can use through laptop only and give. Okay, fine. Use both the devices.
No, sir, my laptop the mic is not working, so that's why.
Okay, fine. You use both the devices.
Yes, sir. Yes, sir.
Okay. So Medha Ansini, can you tell about the 17th assertion? Just say, is it true or false? Okay. How does resistance depend on length? Have we studied anywhere?
Sir, I didn't understand the question.
See, these are assertion and reason questions.
Yeah, sir, I know that one. I didn't understand what you asked that one.
It says the resistance of a given mass of copper is inversely proportional to the square of length. Okay, that means you can write that resistance is inversely proportional to length square. So have we studied anything like this?
No, sir.
No, we have studied that resistance is directly
Directly
proportional.
proportion to length.
This is what we have studied. Whereas the assertion says this one. So now I can say that assertion is false.
Yeah, sir.
So it is option D, sir.
Read the reason. When a copper wire of given mass is stretched to increase its length, its cross-sectional area also decreases. So just think, is it true or false? What will happen to a copper wire if we increase its length? Will its cross-sectional area increase or decrease?
It will decrease, sir.
Yes, sir, it will decrease because the length is increasing.
Yeah, because the length is increasing and volume has to remain the same. So therefore area will decrease. Okay. So this is true. Now which option is to be chosen out?
D
You have the
option.
options here.
Sir, after the class, can you send this PDF in group?
Yeah, just now I'm sending it in the group. If you want, I can just send it now. Okay.
Yes.
Okay, just wait 1 minute. I'm sending it in the group. Just 1 minute. So that whoever wants to access it can access from there only. Okay, you can open up the. I think I have sent it, and you'll find it in the group. Okay. And Amatur Rahman, turn on the camera. Rene Sravani, if you can turn on the camera, it will be good.
Yes, sir.
Okay. So you can open that on your system. You can have. Let's see the question. Just wait. Okay. So you have the question over here. Question number 17 we have done. We need to see question number 18. Okay. See question, electric current flow from a body at 15 volt to 10 volt. So can this happen that electric current can flow from 15 volt to 10 volt?
No, sir. It should be from 10 to 15.
Will it move from 10 to 15 or 15 to 10?
Sir,
Current
we take
always.
voltage as V2 minus V1, sir. So the V2 should be greater.
So it says from here from 15 volt to 10 volt. It's going from 15 to 10. Okay, remember the current flows from high potential to low potential. Do you remember that? Current can flow from high potential to low potential, right?
Yes, sir.
Okay, so this one, it says that electric current flow from a body at 15 volt to 10 volt. Yes, the 15 volt is at a higher potential, 10 volt is lower potential. So the current will flow from 15 volt to 10 volt. So assertion is correct. Okay, assertion is true. Okay. Now about the region. See, electric current flow from a body at a higher potential to lower potential. So first of all, it is true. And secondly, it explains the assertion correctly. Okay. So which option to choose now?
A option.
A option.
Yes.
Okay. We need to choose option A. Then see question number 19. A fuse used in electric circuit has high resistance and a low melting point. So fuse is used in the electric circuit and it has a high resistance and low melting point. Is it correct?
Sir,
That the
it
fuse
has a
has a
high melting point, no, sir.
Yes, and a low resistance.
okay, fuse should have a high melting point and low resistance.
Yes, sir.
So why high melting point and low resistance?
It is high melting point, sir, such that when
So that it does not melt. I'm sorry for interrupting.
But we want it to melt. We want fuse wire to melt. Before the circuit melts, before it catches fire, we want the fuse wire to melt. Right? So which one should be there? Which one should we use now? It should be true or false. See, it's totally true. A fuse wire used in electric circuit, it has a high resistance and a low melting point. Okay. Why it should have a low melting point? Because we want it to melt. That fuse wire is put there just to melt. So that before the complete wire of the house starts melting, the fuse wire should melt before that. So that is why it should have a low melting point and it should have a high resistance.
sir.
Yes.
Sir, if it has a low melting point, sir, that means it should
Hmm.
it should melt when it is not at very high temperature, sir.
Yes, but that is why it is rated. It has some power rating, right? So you have like this. You have your you have your fuse wire, and then after the fuse wire, you have your common wire. Your copper wire that is there. So it's something like this.
Yes, sir.
You have your fuse wire. Okay, this is your fuse, and after the fuse wire, you have a connecting wire. So your connecting wire is copper. Okay, and here you have the fuse wire, which is this is your fuse wire. So this copper wire, see, both of the same current is flowing through the fuse wire and through the copper wire, right? Now the amount of heat produced will be directly proportional to I square. So both the copper wire and the fuse wire, they are going to produce almost the same amount of heat, right?
Yes, sir.
Okay. However, this is having a high resistance. So if the fuse wire has a high resistance, so it will produce a high amount of heat as compared with the copper wire. And therefore, it can melt before the copper wire, which we
Correct.
want, which we want it to melt. Okay. So it is provided a power rating. Power rating means we have calculated that how much temperature will be reached by of the fuse wire. Suppose 5 ampere current is allowed through the circuit. So what should be the melting point of this? How thick it should be? What should be its resistance? So that is all calculated, and hence it is implanted over. Okay.
Yes,
So
sir.
this assertion is correct. Anyone having any doubt about the assertion? Okay. So this assertion is true. Then region. During the flow of any unduly high electric current, the fuse wire melts and protects the circuit and appliances. So first of all, is it true or false?
Sir, it's true.
True, sir.
It's true, and both are true. Also, it explains the region. So therefore, we should choose option A.
Yes, sir.
We should choose here option A. Now, the last one. The commercial unit of electrical energy is kilowatt hour. Is this correct?
Yes,
Yes,
sir.
Okay. And the region is SI unit of power is volt.
it's false.
That's not
False?
correct, sir.
It's
It's
not correct.
false.
SI unit of power is watt, not volt. They're different. Volt and watt are different. Okay. So only assertion is correct. And which option shall be chosen?
C option.
C option then. Case study based question C. These are the case study based questions. As you can see, Rene, what does the table give you the values? What are the values listed in the table? Yeah, Rene, what are the values given in the table?
Are you asking what the mistake is?
No, there is no mistake.
Oh,
What these values are called, which are given in the table?
so the resistivity of the conductor materials given.
Yeah, here you are given the resistivity of the conducting conductors at 20 degrees Celsius. Okay. Now go through the passage. I'm giving you just you can go through it within 2 minutes. The passage is here. We come across large number of electrical devices in our daily life. Each one has a different properties and uses. Different appliances make use of different materials given in the table above. So which substance is used in electrical transmission lines and why? So your options are, you can see your option A and B, and you have your option C and D.
Sir, I
So
think
in,
it's option D, copper due to its high conductivity.
yeah, it is copper due to its high conductivity. Copper has a high conductivity, therefore copper will be used.
Yes, sir.
Then what is the resistance of a tungsten wire of length 2 meter and area of cross section 1 centimeter square? So do this quickly. I think you can do this. If you want the value of resistivity, it is given in the table. The value of the resistivity of tungsten wire is given in the table. Okay. You can obtain it from the group also, or it's here. Let me make it available to everyone. So this is your question. You have the table. Okay. This is the table you have. So do the calculations quickly. Is there anyone who has got the answer?
Yes, I got it.
Yes, sir.
So for tungsten, you need the resistivity. Just one answer I got. Okay, two people have sent the answer. Shreyasi has also sent the answer, and Shravani has sent the answer. Right? So Shravani and Shreyasi, both your answers are correct. Rene, I want your answer also. K. Subha Charvik. K. Subha Charvik, are you able to get the answer?
Yeah, sir, trying.
Yeah. Just which formula to be used, Rene? Rene, which formula is to be used?
It's the resistance into length by area.
Okay. So R is equal to rho into L by A. This is the formula that is to be used. We want to compute here R, not rho. Okay. So R will be equal to rho. What is the value of rho or resistivity of tungsten? You can spot here the resistivity of tungsten is 5.50 into 10 to the power minus 8. So put here 5.50 into 10 to the power minus 8. Multiply length, which is given as 2 meter, and divided by area, which is 1 centimeter square. So area in centimeter square, you need to convert this to meter square. Okay. So 1 centimeter converted to meter will be 10 to the power minus 2 meter, and it's a square. So if you multiply 5.5 into 2, you will get 11. Multiply 10 to the power minus 8 divided by 10 to the power minus 4. Take it to the numerator. You will get 11 into 10 to the power minus 4. So which option is correct?
C option.
C
Option C.
option. Here option C is correct. Amatur Rahman, were you not able to get the answer?
No, sir, I did mistake actually.
Okay. I think you did not convert centimeter square to meter square, right?
Yes, sir.
Yeah. So you must see for the units also. Now see the next one. Okay. Which of these substances is used as electrical heating device and why? So which substance is used as a electrical heating device?
Nichrome.
Nichrome? Yeah.
Sir, I think it's nickel.
Nickel. Okay, let's see what are the things which are given. And out of that, which one? You are given silver, copper, aluminium, tungsten, nickel, iron, constantine, or nichrome. Okay. So which substance shall be used for
It's nichrome, sir. I take back my word.
it's nichrome.
Yes, sir.
Okay. So why we use nichrome?
It is an alloy, sir, and it has a very high resistivity.
It is an ohmic conductor.
Hmm?
It is an ohmic conductor.
It's an ohmic conductor. Okay. So which of them is not an ohmic conductor?
Oh, all of them are ohmic conductors.
See, nickel out of the silver you cannot use. It has a very low resistivity. Copper is not used. Aluminium is not used. Tungsten is not used. Nickel is not used. They are having low resistivity. Highest resistivity is of nichrome. So nichrome is used. Okay. Now out of this, which substance is used in the bulb? In those yellow
Tungsten?
colored bulbs, tungsten is used. Why we use tungsten there?
I just know about it, sir. It's used as tungsten over there.
Yeah, tungsten is used in the bulbs. So why we use tungsten over there and not nichrome?
Sir, maybe because of the melting point. Oh, it's an alloy. It's an alloy.
Tungsten is not an alloy.
High resistivity.
Okay. See, tungsten has a high melting point. Okay. So even if the filament of the bulb it heats up quite large, so to a high temperature, therefore the tungsten will not melt, and hence it is used over there.
Yes,
Now
sir.
see, uh, a constantan wire of length L and area of cross section A is drawn to double its length. What will be the value of new resistivity of the wire? So this is also important one. Just see, try to solve this. You have a constantan wire. And you do not need to use any table values. Without any table values, you can answer.
It will be doubled.
See, constantan wire of length and area of cross section is drawn double its length.
So resistivity becomes 4
Resistivity
times.
becomes 4. Read the
Yes, sir.
questions. Read the options carefully. You started solving. You didn't read the options. Read the options carefully.
Resistance becomes 4, sir. Sorry.
Resistance becomes 4 times. So what option will you choose here? All the options are resistivity. Okay, no answers. Medha Hansini, are you getting? See the question. The question is just word up. Just
Sir, Sir, in that case, won't resistivity remain the same because it depends on temperature?
Resistivity remains the same. The correct option will be option B. Okay. The question is resistivity and not resistance. If it talks of resistance, then you will say the resistance will become 4 times. Okay. So resistance will become the 4 times. There is no need to explanation to this question. You understand this question, but the problem was that you thought it's asking about resistance. Okay. It's asking about resistivity, not resistance.
Yes, it remains constant.
It remains constant. It will depend only on temperature. Okay, see. Then fifth one, what are the factors on which the resistivity of fire depends on?
D.
Option D.
Option D, nature of material and temperature. It does not, resistivity does not depend on length. It does not depend on area. None of that. Okay. So question number 22, you need to solve this out. A student had 2 resistors, 2 ohm and 3 ohm. She has to put one of them in place of R2 as shown in the circuit. The current that she needs in the entire circuit is exactly 9 ampere. Show by calculation which of these 2 resistors she should choose. So here you have the circuit, you have the question. Okay. Okay, so in the circuit, first of all, it's a very direct question. See, in the circuit, you want your total current I should be equal to 9 ampere. Okay. So what should be the total resistance of the circuit? Rene, what shall be the total resistance R of the circuit then? V by I? Okay. So it should be 12 by 9 and 12 by 9 is 4 by 3. Now you can directly compute the answer. 1 by R1 plus 1 by R2 is equal to 1 over R. Okay. Substitute the values. 1 by R1. So your R1 is 4 plus 1 by R2 equals 3 by 4. So your 1 by R2 will be equal to 3 by 4 minus 1 by 4. So what's the answer? Shravani, did you get the answer?
Yes, sir. 3 ohm.
3 ohm or 2 ohm? Solve this out. Solve this out.
Oh. 4. Wait. Two ohm, sir.
Yeah, 2 ohm answer you are getting.
Yes, sir. I didn't reciprocate 4 by 3, so I got 3 ohm.
Okay. Every step is important. See, I can solve this question within a minute, but still I'm doing all the steps, right? So you have to do all the steps. Okay, so shall we move to the next question now? See, out of the two wires X and Y shown below, which one has a greater resistance? Justify your answer. Which wire has a greater resistance?
Wire Y.
Yes, sir.
Wire Y has a greater resistance. It has a larger length.
Because it's directly proportional to resistance.
Yeah, length is directly proportional to resistance. Now find the current drawn from the battery by the network of four resistors shown in the figure. Okay, so see here, let's name the resistances. Let this be R1, R2, R3, and R4. Okay, see how you get this. Okay, I'm giving you some time. Let's say I'm giving you 2 minutes. Solve this, then I will explain. Okay, Amatur Rahman sent the answer as okay. Take your time, solve the answer for 2 minutes. You shall be able to get the answer within 2 minutes. Then. K. Subha Charvik? Yes, K. Subha Charvik?
Yes, sir.
Okay. Renate, try doing it still. I will explain. You are not getting any answers?
Yes, sir. What?
Okay. See, observe the connection first before looking into parallel and series. Observe the connection. Let this be the point A, and the other end which is connected to the battery, that is this point B. Okay. How the current is dividing? Suppose some current I comes from the battery. So this current I comes at the point A. It gets divided into two branches. Okay. First of all, it passes through this branch. Let's say some current I1 passes through this branch, and some current I2 passes through the lower branch. Okay. So the current through current through this branch is I1 current. So I1 current passes through R1. Same current is passing through R2. Same current is passing through R3. So can I say that R1, R2, and R3 they are connected in series? Yes, K. Subhacharvik, are they connected in series or not?
Yes, sir. Well,
Yeah, they all are connected in series. R1, R2, and R3 they are connected in series. Okay. So what will be the resultant of R1, R2, and R3?
30 ohm.
30 ohm. And how is this resultant connected to the R4? Series or
Parallel.
parallel? In parallel. So this is connected in parallel to R4. So therefore, you will get your this R1 plus R2. In the series, you have answer as 30 ohm, and the final answer, that is 1 by R, will be equal to 1 by 30 plus 1 by 10. Now you need to take the LCM, that will be 30. This will be 1 plus 3, that's 4. So 1 by R is equal to 4 by 30, and therefore the equivalent resistance R will be equal to 15 by 2 ohm. Now computing the current, our target was calculation of the current. So current I is equal to V by R. I is equal to V is 3. So 3 divided by 15 into 2. Okay. So 3, 5, you get 2 by 5 ampere, which is 0.4. So I don't think anyone has got this answer. No one got the same answer. Everyone made mistake somewhere or the other. Medha Hansini, did you get the answer? Go slow. There is no need to hurry.
Yes.
Go slow. I want you to learn. Just even if you learn one question, that's enough. But learn it. Do not go it fast. I just want you to learn the question. Okay. So 20 question number 25 is easy one. Let's see question 25. VI graph for two wires A and B are shown in the figure. If both wires are of same length and same thickness, which of the two is made of material of high resistivity? So as you can see, A and B. So which wire has the highest resistance? Shravani, which one has the highest resistance out of A and B?
Sir, I think it's A because it has a bigger slope.
A has a bigger slope or B has a bigger slope?
So how can we?
A
You
has a
have the
bigger
greater
slope than
slope,
B,
sir.
sir.
See, for this, always remember a trick. Okay. Draw the angle theta starting from V. You have to start from V. Wherever V is there, from there draw the angle. Okay. Wherever you get the bigger angle, that will be the bigger slope.
Sir, also sir, they're now asking about resistance, sir. They're asking about resistivity, sir.
Yes,
So
sir.
yeah, they are asking about resistivity, but
And
the thing is same as R equals rho by L, and since length and area of cross section are same,
Yes, sir.
okay, length and thickness they are same. So if length and area are same, resistance will be greater of those which has a higher resistivity.
Yes, sir.
Okay, so I think from V, if we draw an angle to A and draw an angle to B, so B will have a higher, greater angle. Okay, so B has a higher resistance and B has a higher resistivity also. Okay, in most of the question, you will observe some different things. In some of the question, you may find that V is plotted over here and I is plotted over here. So in that case also, you draw the angle starting with V like this. And so in that case, your A will be having like this. Understood the question? Okay, now let's see the 26th. Try doing question number 26 then. Try doing this. Two registers you are given. You are given two registers with resistances 5 ohm and 10 ohm are to be connected to a battery of 6 volt so as to obtain minimum current and maximum current. So how will you connect the resistances in each case? You want minimum current, then how will you connect them? You want maximum current, then how will you connect them?
So maybe for minimum current, we can go for a parallel resistor.
So
And for
that is the
maximum.
yeah, that is the mistake that question wants you to make.
Sir, it's asking for current, sir, not resistance, sir. It should be in series.
See, current I is inversely proportional to resistance. So I equals to V by R. You have to choose the one by which your resistance becomes the minimum. That will be the maximum current. And if resistance becomes the maximum, then the current will be minimum. So how you will get the minimum current?
Series connection.
Series connection. Okay, for the minimum current, R should be maximum. Minimum current means resistance should be maximum. Okay, and therefore we have to use the series combination. So for the first one, we'll be using the series combination. For the second one, we will be using the parallel combination. So A has been solved. For the second one, calculate the strength of total current in the circuit in the two cases. So can you obtain the value of current in both the cases? Obtain the value of current in both the cases. Okay, got the answers?
Yes, sir.
First, you need to compute the resistance and then the current. Okay, so Shravani, what was your first answer?
Sir, I got resistance as 5, so current will be 6 by 5. So, sorry, 6 by 15, right?
6
And
by
for the other
15.
one, it will be 6 by 0.3, which is, yes, sir.
Okay, so this will be
I realized that I
okay.
didn't do the current, I only did the resistance. So, one
Okay.
Yeah, I got
So
it
for the
0.4 for the first one.
see, you can always use this formula if you are in parallel. So in parallel, you can use the formula for two resistances as R1 into R2 divided by R1 plus R2.
Yes, yes, yes.
So if you
LCM
multiply,
reciprocal.
yeah, LCM reciprocal. So that's you will get here 50 divided by 15, right?
I got 10 by 3 in the end, sir.
Okay, 50 by 15, that's 10 by 3 only. So I2 will be 6 divided by 10 by 3. That's 18 by 10, and then it's 1 by 8, 1.8 ampere.
Yes, sir.
Okay. So I think everyone has got all these answers. Today you have been able to practice about assertion and region questions. You have also practiced some of the short questions, right?
Yes,
Yes.
sir.
Yes, sir.
Okay. So there are a few more questions which I will be sending for you. Just see question 2, 27 and 28. Try doing these questions. Right now you have 4 minutes, and within 4 minutes now I will not be solving these questions. I will just check out your answers at the end. So you have the time, solve these in your copy, in your notebook, solve them, and send the answers in the message, in the chat section only, not in the message.
So the first part of the question is the derivation, no, sir. So
The first
the
part is derive an expression for equivalent idea that you can leave out. Last one, how can 3 resistors of 6 ohm can be connected to give a total of 2 ohm and 9 ohm?
yes,
Okay. So I'm getting some of the answers. Hmm. Amatur Rahman has given one of the answer. And in the 28 also, you just need to do the B part. Okay, so I think just go practice these questions. Okay, just take a screenshot of this, or I think you have in the group. So from the group, you can practice this 27, 28. Okay. Also in the group, you will find your all the other questions like previous year board questions are also there from here. And at the bottom, you have your answers also. So at the bottom, you can just look for your answers. All the answers are there at the bottom. Answers with explanations. Okay. So you can visit them. All of them are there. Once you solve, all the solutions are mentioned. Okay. So bye everyone. Practice it at
Thank you,
home.
sir.
Okay. Good
Thank
night.
you so much, sir.